Dear students of class 11, how are you all? I hope by the grace of Almighty Allah, all of you are well. I am also well. This is MD Asghar Khan, Senior Lecturer, Department of Mathematics, Milestone College. Welcome all to our today's class. Today I will discuss about your higher mathematics, chapter 1. Today I will teach you a creative question of this chapter, matrix and determinants. Okay, dear student, now we can start our today's class. Okay, dear students, our today's creative question. Here, this is system of linear equation with 3 variables is given. Now, first question. If this is a expression, we have to find out the matrix F from this given condition, but question A not related to our given information. Okay, and here I2, here this is I2 and is an identity matrix. I subscript 2, that means 2 by 2 identity matrix. Okay, and now question number B, expressing the equation in the form of Ax is equal to B and show that determinant of A is equal to L minus M, M minus N into N minus L. Here A is a matrix which is created by the coefficient of x, y, z, and X is another matrix which will be created by the variable x, y, z, and B is another matrix which will be created by the constant term of this system of linear equation. Okay, and question number C, the matrix A is formed by the coefficient of x, y, z, then find the inverse matrix of A. If A is created by the coefficient of this system of linear equation, then we have to find out the inverse matrix A, where L is equal to 1, M is equal to 2, and N is equal to minus 1. Okay, now dear students, we want to solve this creative question. At first we want to solve this question number A. Okay, dear students, solution of question A. Here this is given. We have to find the matrix F where I2 is an identity matrix. Okay, dear students, here solution of question A, given 2 minus 1 plus F is equal to I2. Multiplication of this matrix by 2 is equal to 2, 4 minus 2 plus F is equal to I2. I2 is a identity matrix which has a 2 column and 2 row. Okay, now F is equal to I2 is identity matrix where 1 0 0 1, because this matrix is 2 by 2 matrix, then I2 is identity matrix where 2 rows and 2 columns. Okay, is equal to, and F is equal to minus of this matrix 2 4 minus 4 minus 2. Okay, minus of 2 matrix is equal to one minus 2 is equal to minus 1, and 0 minus of minus 4 is equal to 4. It will be plus, because minus multiplication of minus and minus, it will be plus. So answer is this is 4, and 0 minus 4 is equal to minus 4, and 1 minus of minus 2, 1 minus of minus 2, so it will be 3. 1 here, 1 minus of minus 2, so it will be 3. So 1 minus of minus 2, it will be 3. This is our answer of question A. Expressing the equation in the form ax is equal to b, so that determinant of A is this. Okay, at first this equation convert into this form. Okay, here solution of B, question B, ax is equal to b, if this equation convert into this form, what is A? You have to know what is A, what is X, and what is B. A will be a determinant matrix. A will be the matrix which is created by the coefficient of x, y, z, and X is a matrix which will be created by the variable, and B is a matrix which is created by the constant term. Okay, now here A matrix will be created by the coefficient of x, y, z. Here this coefficient of first equation is 1, 1, and 1, and second equation L, M, N, and third equation L square, M square, N square. Okay, A will be the matrix which is created by the coefficient of x, y, z. Now X is another matrix which is will be created by the variable of this equation x, y, z. Is equal to B is also a matrix which is created by this constant term. If the multiplication of two matrices is converted by this left hand side of system of linear equation, and this is another matrix, by equating the two matrices, then we will get this system of linear equation. Okay, so here A is this. Okay, we have to find determinant of A is equal to this. Now our matrix A is equal to okay, we have to find the determinant of A. Okay, now determinant of A is equal to 1 and L okay, here the determinant of A is this. The determinant, this is a matrix. The determinant is denoted by this way. Okay. Now you want to change the column 1 by subtracting column 1 and column 2. Okay. So 1 minus 1 is equal to 0, L minus M is equal to L minus M, and L square minus M square. So column 1 already changed, and now we want to change the column 2, subtracting column 2 and column 3. So it will be 1 minus 0, 1 minus 1 0, and this is M minus N, and this is M square minus N square. Okay. So the third column will not be changed, 1 N N square. So our side node is column 1 changed by column 1 minus column 2, and column 2 changed by column 2 minus column 3. Okay. Now after applying the algebraic formula of A square minus B square, A plus B into A minus B, so L square minus M square is equal to L plus M and L minus M. So from the first column we can take a common L minus M. So L minus M is a common term because it has L minus M, and here by applying the algebraic formula L plus M and L minus M, so L minus M we can take a common from the first column, and similarly from the second column M minus N is a common term. Here in this 0 and here is 1, it will be 1 and it will be L plus M, because by algebraic formula the remaining term after take a common L minus M, the remaining term is L plus M. And similar way in this column it will be 1 and this is M plus N, then third column will not be changed. Okay. Now in this term, in this expression, okay, after expanding this determinant by the first row, so first two element is 0, so and third element is 1, so first two element not mentioned in this line, no need mention in this line. So after omitting the first row and third column, because it lie in first row and third column, one is like, so here 1 1 L plus M and M plus N, this is 1 because this is 1. Okay, M into M minus N, and multiplication of this way is equal to M plus N minus L minus M. So L minus M, M minus N, and N minus L. This is the determinant of, this is the value of determinant of A. So determinant of A is this. This is our proved of question B. Now question number C. Here the given information, 3 equation, system of linear equation. The matrix A is formed by the coefficient of x, y, z. Find the inverse matrix of A where L is equal to 1, M is equal to 2, N is equal to -1. So our solution of question C. Here A is a matrix which is formed by the coefficient of x, y, z. So our matrix A will be matrix A, 1 coefficient of x, y, z 1 and 1, the of equation 1, and this is L M N, and this is L square, M square and N square. Now after replacing the value of L is equal to 1, M is equal to 2, N is equal to -1, then the matrix A will be okay, L is equal to 1, so A is equal to, the first row will not be changed because all elements are 1, and L is equal to 1, L is equal to 1, and M is equal to 2, so here is 2, and N is equal to -1, and L is equal to 1, so 1 square is equal to 1, and M square is equal to 4, and N square is equal to 1, -1 square will be 1. So this is our matrix A. We have to find the inverse of matrix A. Okay. For the inverse matrix, at first you have to determine the matrix A. Okay, so determinant of matrix A is denoted by this. Okay, and now determinant of this matrix. So we can find the determinant by the expanding the first row, here 1, then ignore the row and column, 2, -1, 4, 1, and here is -1, then ignore the row and column of 1, then 1 -1 and 1 1. Now the third element is 1, ignore row and column, then our element, our determinant 1 2 and 1 4. Okay, so here the multiplication of these 2 plus 4 minus 1 plus 1, and here 4 minus 2. Okay, so 6 minus 2 plus 2 here is equal to 6. This is not is equal to 0. So our inverse matrix is exist. So exist. Okay, now we want to cofactor of each element. Okay, now cofactor of each element of matrix A. Now cofactor of this element, this element is 1 1. here is A11 is equal to by of first element, then ignore row and column, is equal to 2 1 2 minus 1 4 1, then is equal to 2 plus minus 4, then it will be plus 4 is equal to 6. But the sign of our cofactors respectively start from here plus minus plus minus plus minus plus minus and plus. Okay, so we can follow the sign of cofactor by this way, starting plus minus plus, then minus plus minus, then plus, then minus, then plus. Okay, now here the first element is 1, so cofactor sign will be plus. Okay, so answer is 6. And now for this element is 1 2. Okay, so and ignore the row and column, 1 minus 1 1 1, so sign of this is minus. So here 1 plus 1 is equal to minus 2, and 1 3, ignore row and column, the sign is plus. Okay, 1 2 1 4, so ignore row and column, 1 2 1 4 is equal to 4 minus 2 is equal to 2. Okay, now for this element, this is the element which is denoted by the second row first column. So second row first column is equal to, okay, ignore the row and column, then 1 1 4 1 is equal to 1, the sign is minus. Okay, so 1 minus 4, and here sign is minus, is equal to 3. Okay, now A 2, this element is 2 2 is equal to, okay, for this element, then ignore the row and column, then our element is for this element. Okay, ignore row and column, then our element is 1 1, this element 1 1 and 1 1. Okay, this sign is positive, 1 minus 1 is equal to 0. Okay, now A 2 3. Okay, for the A 2 3, for this element, ignore row and column, then 1 1 1 4. So this sign is minus. Okay, so our answer is 4 minus 1 is equal to minus 3. Okay, now for the third, now similarly for third row, A31 for this element, and for this element A32, and for this element A31. For this sign is positive, and for this sign is negative, for this sign is positive. Okay, just for 4 sign is negative. Okay, here this is equal to minus 1 and minus 2 is equal to minus 3, and this is equal to minus 1 and minus 1, this is equal to 2. Okay, for this 2 minus 1 is equal to 1. Okay, already we have we have got the all cofactor of this matrix. Adjoint matrix of A. Already we know the adjoint matrix of A, the which is created by the all cofactors of matrix A, transports of all cofactor of matrix A. This is the transpose matrix of all cofactors of matrix A. Okay, already we have find the value of A, the all cofactor, which is A1 1 is equal to 6, and A1 2 minus 2, A1 3 2, A2 1 3, A2 2 0, and A2 3 minus 3, and A3 1 minus 3, A3 2 2, A3 3 1. Already we have find this value from matrix A. So what is the transpose of this matrix? This is transpose matrix is the interchange of row and column. So this is row and it will be column, and 3 0 minus 3 and minus 3 2 1, row and column interchange each other. Okay, this is the transpose of this matrix is this. Now this is the adjoint matrix of A. Now we know our inverse matrix is equal to, okay, our inverse matrix of A is equal to, A inverse is equal to 1 by determinant of A into adjoint matrix of A. This is our formula of inverse matrix. Now according to this formula, our answer will be A inverse minus 1 is equal to 1 by determinant of A is equal to 6, and our adjoint matrix is 6 minus 2 2 3 0 minus 3 minus 3 2 1. Okay, here the inverse matrix of A inverse is equal to this. This is our answer of question C. Dear student, this is our today's class.